Hello, everybody. I'd like to start my talk today with like the only reason why I attended math club. So that was like in January 2022. And the only things I knew about math club was that they have free pizza. So I came here on like my first Friday evening and I went there and there was like just a few people. So at the end of math club, Prof. Jim said like, yeah, you all need to get all the pizza because that's the rule of math club. Every pizza needs to go home. So I brought home like 1 box of pizza and I ate it like uh breakfast on Saturday, lunch on Saturday, dinner on Saturday, and I ate it until Monday, and it was very, very dry. So that's like our first thing for today. Don't bring a hot pizza. Like, I don't think there will be a lot of pizza left today, but next time or any other time, one whole pizza is like too much for one person. Maybe just half. It's gonna get in through Saturday, and it's gonna be good. Yeah. So yeah, got it. Let me now talk about myself. My name is Antsa. So it is written A-N-T-S-A, but the final A is silent. So you call me Antsa. And if you want to know more about that person, there is this QR code right here. So you take a picture of it. You can go, this link goes to my personal website. And also I like to write about stuff. So this link right here will lead you to my Medium page. And like the most frequently asked question about me, like when people see me and talk to me, like where do you come from? Then the next question will always be, how did you learn English? When did you get the best test? How did you pass the best test? So I was sick of those questions. So I was like, no, you all go to this link. I write everything there. You all go there. Don't ask. You can still ask me, but I will probably just add it to this. The second type of questions that is like asked is like, did you pass the prelim? What kind of prelims did you take? I also write that here. So that's also like a trick for you guys. If somebody asks you a lot of questions, just write it, put it down there. Just refer to it next time. So yeah, that's about me. That's about what I am doing. And kind of, we had a question like, why should we learn finger calculation? So I have a fun fact about me. I was born with fingers, like I have 10 of them. And when I started going to school, I was taught that like to add numbers, I need to have them in my hand and count my hand. And then I grew up and they say you need to have like 8 in your head and 5 in your fingers. And then later they say like, no, you are grown up now. You do mental math. You shouldn't be using your fingers anymore. And then high school happened and they say like, yeah, there is this devices that's called calculators. So you all should learn how to use them. That's what you are going to be using. But then I arrived in graduate school and they say, this preliminary exam, this exam, you shouldn't be bringing calculators. So know what? Like, why? So I don't know, like, but I will not discuss about that right now. Let's just learn finger calculations because yeah, calculators are not allowed in some exams, and finger calculations are definitely faster than the usual way, which is like writing down everything. Like most of the case, using fingers is faster. And also when you know how to calculate with your fingers, it requires less memorizations. And also sometimes even with the calculator, it's better to just do everything on your hand instead of like taking your calculator in your backpack. That's slower. So, but also we should learn finger calculations because it's just fun. So I didn't learn finger calculations or any things like that in school. because yeah, they think that math is not about calculation. They feel like you need to know the things, and calculation is the job of calculator, but now I need to do so. Also, most of those were I learned them like in a very like I would say like informal setting, which is like talking to people who are like, hey, I found this cool things. Do you know about it? And I was like, no, nobody told me about this. Some of them also come up when I was studying, when I'm doing my bachelor's and I took a class on history of math. And there was like those old people, like from a long time ago, they know things that we don't know anymore, and they like very cool. So yeah. So I was going to in the internet to see like why don't people teach something like this in school, and this screenshot from Wikipedia like captures most of the things that the argument there, which is they say like yeah, like when you are using finger calculation, it doesn't teach you how to do the math. It's just have you like doing things very fast, but you don't understand the basic. But if you are in this room right now, I definitely believe that we all know the basic of calculation. So let's learn how to do it fast. So this is like us practicing. It's not like me just talking, it's everyone participating. So I would like to ask, how many of you have ever seen the multiplication by 9 using your hand? Okay. Can you Leslie come here and explain to us how that works? I think you can think you should put the pizza in the plate there.
Okay, I think 9 times 4. Well, I guess I'll do it backwards. So you count 1, 2, 3, 4. You put this down. Am I doing it right? Is this how you learn?
You just explain. You just tell us what you know. It's
okay. And now you have a 3 and a 6. Yeah, and it works with all the rest too.
Yeah, thank you so much. Yeah, that's it. So yeah, when we have like when you want to like 9, we have this finger. So like you like if you want to what 9 times 1 is just put your 1, hide your 1. So now you have just I think it should be like this way. That's how I read them. So it's like 9. Now 9 times 2, 1, 2, hide the 2. Now you can read like 1 and 8. So that's 18. Now 9 times 3. 1, 2, hide the 3. What do you read here? I read 2 and 7. So that's gonna be 27. The same for 9 times 4. We hide the 4 and have 1, 2, 3, we have 36. Isn't that cool? It's really cool. So it's work with all of them hand. So when we have like 9 times 10, we have like this. So it's gonna be like, just think of it as like the one that is on the left of the things that you hide. Those gonna be like your number of 10. So it's gonna be 90. That's yeah. It's also recorded, so you can say it on YouTube whenever it comes like to refresh. So now we are gonna see how many of you knows how to multiply numbers using your hand. It's like, let's say, how to multiply 6 times 6, 7 times 8, or 8 times 6 with your hand. Has anybody seen that before? Okay, let's start. So the way that we are gonna do it is in each of those numbers, we are gonna subtract 5. So we have 6, let's start with 7 times 8 because that's the easiest. So we have 7 minus 5, that's gonna be 2. So we raise 2, we hide 3. And here we have 8, which is 3 times 5. So we raise our 3 and hide our 2. Now, when we multiply 7 times 8, what we are gonna do is those ones that are raised, those gonna be the number of tens, are the one that we hide, those will be the numbers of our units. So we have 56. The way we are going to do this, those, the one that are raised, we are gonna add them. And the one that we hide here, we are gonna multiply them. So here we have 56. 7 times 8 is 56. Don't ask me why that worked, it just worked. And yeah, so the same goes for 8 times 6. We have 8 again and 6 like this. So now we have, yeah, what is the number of tens? We have 4 of them. And what's going to be the number of units? We have 2 times 4, which is going to be 8. So that means that 8 times 6 is 48. So it's really cool. So how about 6 times 6? So here we need we need to do a carry the 1 because here we have 2 tens, but we have 4 times 4, which is 16 units. So we have 16 units plus 2 10, and that's going to give us 36. Are you feeling good so far? So now we're gonna, that's about multiplication. So we were talking only about how to multiply things that are more than 5, like 6 to 9. Now we are gonna see how are we gonna do the smaller numbers. And we learn in primary school that to multiply things is to repeat itself, let's say to multiply 4 times 4, that is 4 plus 4 plus 4 plus 4. So that's what we are going to do using our fingers. So we need to first learn how to represent the numbers with your fingers for addition. And this is this part right here, that's the Chisanbop part. So I did the reason that I decided to go this talk is I didn't know that thing has a name. So I saw this on YouTube and I thought oh, it has a name. I think that's pretty cool. I'm gonna email Prof Jim immediately about this. I didn't know what the other things are about, but I just this pretty cool. I like the name. I mean, I'm gonna talk about it. So to represent a number with your fingers, it's kind of pretty weird because it's not how they taught us that before. So here's the thing: we are gonna start with 1. So that is 1. 1 is this. 2 is this. 3 is this. 4 is this. But when you are doing 5, we are gonna do our thumb is 5. So now when we are gonna do 6, 7, 8, 9. So with this one finger, we can represent, with this hand, we can represent 9. So now this is going to be our units, and this is going to be our tens. So that means that with those 2 hands using the same techniques, we are going to be able to represent 99. They say that you can also learn how to have I think it's 9,999. You can do that, but I was not really interested in learning that. I think just being able to represent 99 with my hands are pretty cool. So how do we add, so that's how we perform addition. So let's say we want to represent 64, that is this, remember this is my tens, and this is our 50, so it's 64. So that's it. Yeah, so let's do like some addition. Let's say we have my pen is going on strike. So let's say it's just let's say it's like very basic. Let's just do 2 plus 2. You know how to do that, right? So like let's say in primary school you have 2 and then you need just to rise 2 more. So 1, 2, and that's like 4. Until now it's just pretty basic, and you can also do that like if you don't have any carry on. But now it's become crazier when you have to do something like 4 plus 3. How do you do that? Again, always have like the bigger first. So we have like 4. Now when we want to add 3, know that we just need to count 3. So when we want to move to the 5, we just need to say 1, 2, 3. So when you want to pass through the 5, you just hide all of the 4 together, and then you just count like 1, 2, 3. So we see that 4 plus 3 is gonna be 7. And you can always practice a lot of that, but I think you can do it on your own time. I think it's just like really, really cool. I will also include the books that you can read if you are interested in more of those, but I have a lot more stuff that I would like to show you because I'm so excited about them. So that's like, yeah, this is like when we have addition if carry the one of 2 numbers. So this is like, just let's say we have 14 plus 9. So we just represent 14 like this, and then we are gonna add 9. So just we are gonna count again, since it's 14. When I count 1 after 4, I add everything and I put my 1. So let's count. So 1, 2, 3, 4, 5. Oh, there will be like 4 left. So now because it's gonna be 10, so I am gonna put this together like this, and so now 1, and then when I have this, then we go back here again. So it's like 1, 2, 3. I think I lost track. But yeah, you get the thing. Every time that you are 9 and you need to add 1, you just close everything together and keep your 1 in the text, and then at the end you just look at your hand and see what do you have as tens and as your units. So yeah, so that's how you do, like when you do multiple numbers, you just do like what we did for 2 numbers, just you need to start with the bigger one so that it's gonna be easy, and that's how we can do for multiplication of small numbers. So now we have the tools that we can use to multiply small numbers and big numbers. So what we can do, we can now start doing multiplication of like bigger numbers. So let's do it. So suppose we want to multiply just how many here. So we have, I didn't prepare this before, so I don't know what the answer is. So let's put this. I'm just gonna edit it. So let's say we have 7, we have 8, we have 6, and we have, why not have 0? And then just like 1, 2, 3. So that's the multiplication that we would like to go. We have this number 7,860, which we will multiply by 123. What we already know is how to multiply digits and how to add numbers. So that's the things that we are going to do. So first step is we are going to put all of the result of this in those tiles. So we start with just do everything like 0 times 2, that's got the 0 times everything is going to be 0. So let's just put 0 everywhere. Right? Now, we just like it really doesn't matter where you start. So we have 6 times 1, it's going to be 6. So the top one is going to be, again, the top one is going to be the 10th, and the bottom one is going to be the unit. So we're going to have 0 and 6. 6 times 2, that is like 6 plus 6. You know how to do that. It's going to be 12. Now, 6 times 3, that's going to be 18. And 8 times 16, we have 8 times 3, that's 24. 7 times 21, 7 times 2 is 14, and 7 times 1 is 7. So it's pretty easy right there. So now what we are going to do is you're just going to add those. Just add. So this is going to be 0, 0, 0, 8. That's going to be 8. 2 plus 1 plus 4. That's going to be 7. That now we have 6 plus 1 plus, oh, that's going to be 16. So we put 6 here and we just add like our 1 here. So it's like, yeah, we just add it on the next one. So we just had, this is going to be 10 plus 6 is going to be 16. And it's going to be 8. So now the answer is going to be 8, 6, 6, 7, 8, 0. All right. So it is called lattice multiplication. I don't remember who came up with it, but it's very old, pretty old. And yeah, this next part right here is, I don't know why it's doing like that, but I found this on a YouTube channel that I don't remember anymore, but I think it's pretty cool. Like, how do you do a matrix multiplication in a way that is not confusing which one goes which? So, let's say we have a matrix multiplication like this. Okay. 1, 8, 3, 2, just making up numbers. And 13, 5, 2, 5, 6, and so it's gonna be our.
I should randomly just put in like 13 digit number.
So that's right. And all of them. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. So how do you do those matrix multiplication? So when you are looking like this, you are like, oh, just like write this and do. No, let's not do that. Let's not do that. Let's just take, oh, let's just, oh, 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 bonus track. I need you. So let's just move it here. Why do we move it there? Because now it's very easy. We already know what the shape will be. And we already know from here that this part right here and this part right here, we goes on this. This part right here and this part right here, we go here. And this with this is gonna be here. This and this is gonna be here. And yeah, those are just addition and multiplication again. So it's not confusing and it's cool. It's pretty cool. So yeah. So that's about calculation. Now let's go back to the old days where we were only asked how to count. So I have a problems for you. How many squares are there in the tree? And let us all work on this like for 2 minutes. And then I'm gonna ask anyone figure out the answer. How did they do it? So let's start. I'll start. Raise your hand if you have finished. Show me with your fingers how many of them did you see? Okay, it looks like a lot of people get some good get the way to do it. So can you please have Adam explain? How did you get it? Yeah, come up here.
Sure. Correct. So I just started. So first of all, this one, you can separate these out because they don't form squares with other things. They just form squares with each other. So you have 1, 2, 3, 4, 5 times 2. And then there are different sizes that you can go with. Since it's square, it has to have the same width as height. So you can just go through 1 by 1. That's 16. Then you go 2 by 2. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's 3 by 3. That's 1, 2, 3, 4. And then there's the big one, 5. And then I kept on going through that over and over again. I just counted it up. I wound up at 40.
Yeah. Did you all get it? Like at least when we didn't get the 40 yet, did you get like the idea of how did he started counting this? Okay, you still have like another chance because I have 4 of them. So let's practice here. Triangles. Triangles.
all put together?
Oh no. Let's just do this one. Like once you get the way to do things, you can do a lot of stuff. I just want to start thinking of how we should do this. Oh, let's show your answer in your hand. You already done. Okay, I'm trying to already finish your pizza. Can you please come here and finish it? Oh, okay. Suppose you have finished your pizza.
All right.
Can you please explain us how did you come up with that?
So what I did was I saw if I have one little triangle right here, well, if I look down here, there's no triangles on their own without the top. And so I can just look at the top here. Here's one little triangle, and that little triangle can be extended 2, 3, and 4 of them. And so I just have to count how many are up top and then multiply it by 4. And so it's one little triangle, 2 little triangle, 3 little triangle, one medium triangle with these 2, a second medium triangle with these 2, and then one big triangle there. So a total of 6 of them multiplied by 4 is 20.
Smart in this room, right? So I like this one. I first noticed when I was in grade 3, I think my teacher wanted just to do grading on the thing that she should be teaching. So it's like, hey, I have these cool things that I have you to do. Would you please like draw this on sheet paper, but you must draw it on a continuous line without lifting your pencil from the paper, and you can't draw the same line twice. So I think as a third grader, we spent like maybe an hour before somebody figured out how to do it. So we are all in college, so I think we will only take like, let's say 2 minutes to do this. But yeah, let's do it and raise your hand if you figure the answer. Yeah. How about you? You can come here. I'm so sorry I don't know your name. Like, I don't know most of you get his name, but we're gonna work a bit. So how about you take should be chalk somewhere. I don't use chalk, so I don't know about that. Okay. Sorry. Hey, I saw you doing this twice. I saw you. Yeah. Yes. Now you did it once. Yeah. Now you did it like everything else. So Miles. Okay. You can sit down, Miles. So Yeah, so as we see here, he started from this part right here and this part right here. So just take a mental note of what's happened on those two corners. Just very quick mental notes because we're gonna move to the next one. Did you get it? Did you take a picture of it in your mind? Okay. Now, what about this one? How about this one? Can you do the same things? Can you? 2 minutes, that's what you will have. Raise your hand if you find the answer. Anyone have an answer about that?
I think I find out.
You want to give it a try again?
Yeah.
You can come. Just raise your hand on your seat if you have like any idea of, is it if you have an answer or you think that it's okay. Let's see what else is doing here. Yeah. It's the like SpongeBob. I really appreciate your enthusiasm, but the answer is it's impossible with this. It's impossible. So that's why I told you guys to take a mental note on those corners right there. Why is that? Because you know, those when you are looking at those all of those corners right here, all of the other corners, they have and even numbers of edges from them, but only those two have odd numbers of edges coming from them, and that's why there's a lot of puzzle. Like if you are really interested in like the math theory behind this, that is taught in graph theory. So yeah, there are a lot of books about that. I am not gonna teach you that, but I think it's just really cool, and it's just like a pretty cool trick that you can have with your friends. So here's the idea: is that if you are gonna go and if you're gonna come into an corner and leave from it, that needs to make two edges. So that means if you want just to start and not to leave, you only need like one. So that's why you should only start with something that has an odd numbers of edges from it. And there should only, if you want the traveling to be feasible, you should only have 2 of them, because if you have like more of them, that's not possible. If you have like this part right here, all of them has 1, 2, 3, 4, 5. This has 5. 1, 2, 3, 4, 5. This has just a lot of them. So all of those odd like corner that has odd number of edges from them, they should be either a start or a finish. So you cannot have more than start or finish. So just you can come up with a very, very crazy drawing. If you respect that things, you look like a genius. But yeah, that's just graph theory. You can look at it, like you can learn that from books. So those are also some cool things that you can try doing. Just apply the rule. If you have like if you have only 2 of the vertex of the corners that have 2 edges that have odd edges, then you can do it. If not, then you just can't. Now, what do you see here? What are you looking at? What are you looking at?
Checkerboard.
Yeah, the checkerboard, a normal checkerboard, right? You can try some, like you can try them like on a piece of paper. So no, just slide this. No. See what's happening? See what's happening? Do you see what I see? Yeah, they don't do that. Like, yeah. Isn't that cool? That's really cool. Yeah, you can do that. Just create a checkerboard, cut them, just slide them, arrange them. You are gonna get this, they are gonna look at it, but they are not. They were just normal checkerboard. And they were just slide a little bit. Yeah. So this is like, if you want to like do a drawing and like pretty cool drawing, or maybe also like if you are and you want to say that you are a genius in drawing, you can use this. We can do fractal trees. So fractal is like a term in mathematics that say there is a shape that repeated in like its pieces. So you have a bigger piece, but when you are zooming on this, then you are zooming on the bigger piece, you are gonna see the same things again, and it's gonna be repeated. So how do we draw fractal trees? Just let's gonna draw a tree trunk with 2 branches. So this one right here, and it have 2 branches. Now each 2 branches, they have 2 branches. Now each 2 branches have 2 branches. Now 2 branches, 2 each. Now I'm gonna get a green and oh no. Oh. Now we have our really good tree, and we can even show like pretty cool bird. Oh, it's not visible, but it's cool. So that's our tree. Pretty cool, right? Yeah. I think you have all seen this before. Do you know about Pascal triangles? So Pascal triangles they were used when you were started learning about what is it? I call them like familiar patterns, which is like you have the square of a sum, the cube of a sum, something like that. So never used this before. It's just meant you have this is like you have a plus b to the 0 is just gonna be 1. Now if you have a plus b to the 1, it's gonna be a plus b. This row here is like if we have a plus, can you see what I'm writing here? Okay. If you have a plus b squared, then it's gonna be just right here, 1 times a plus 2 times, a squared 2 ab plus 1b squared. So yeah. Now we see that this is for 2, this is for 3, this is for 4, this is for 5, this is for 6. So when we have a plus b to the power of 6, it's pretty cool. We can pretend we are a genius. Yeah, we are genius. But yeah, this is like a shortcut. So we have 1/3 equals to plus 15 plus 20 plus 15 plus 6 plus 1. We put A, B, A, B, A, B, A, B, A, B everywhere. And then, so for the A's, we are going to start with 6, 5, 4, 3, 2, 1, 0. So here we are going to do, for the B, we are going to do 0, 1, 2, 3, 4, 5, 6. Yeah, but that's like the basic idea of Pascal triangle. If you obviously feature first time doing that, but what's pretty cool about them is like you don't need to remember those. What you do is when you look at this, you just see that this next one right here is just 1 plus 1. That's the 2. When you are looking for this 3 right here, it's just 1 plus 2. And same here, so you can populate this table until you get like 100, 200, 300, and yeah, that's just what we did before, just adding, right? Easy, right? But now, when we complete this triangle, there is magic happening. So when you are looking at this, so the first thing that we are going to see is that this first thing is always going to be 1. The next thing that we are going to see is that this line right here, it's just counting, right? 11, 12, 13, 14. So that's this first diagonal right here. Now, all of those lines here, they have like a lot of cool things about them that I will not have enough time to talk about here, but I just gonna give you like the taste of how cool they are. So if you are interested about learning about Pascal patterns, like most of them, I would not say most of them, just a lot of them. There is this QR code here that you can learn about them. So just take this picture and you have it. So I am like 2 slides and 10 minutes left. So I have this problem here. I've seen this problem before. I don't know if I've ever seen it, but could you explain, like, could we please take 2 minutes of time to think about it and raise your hand if you know the answer? Just read and raise your hand if you have the answer. That's a different subtraction. Raise your hand if you think you know what's happening. Grant, could you please explain that?
Yeah, the $2 that they paid to the assistant. So each friend was paid $9. They paid the $10. They each got $1 back. The $2 has already been counted in 27, but that additional 3 that they have is what you get.
Yes, that's definitely true. So you are being given like the wrong problem and you were adding or subtracting the wrong things. What the Alstrand says is like in this problem, they definitely get like they were paying $27, but like the 2 that they give to the assistant is already counted as part of their 27. It's not that they already get their actual change. Yeah, the actual changes. So the change is 3. What they pay is 27. That's add up to 30. This is just like making fun of you. Making fun of you. Yes. Yeah. So our last problem for today, the farmer's pig. A farmer wants to put her 9 pigs into 4 pig pens so that there is an odd number of pigs in each pen. How can she do this? How do you put 9 pigs in 4 pig pens so that there is an odd number of pigs in each pen? Take 2 minutes. Solve this. Raise your hand if you think you have an answer. Okay, come on, Samuel. Let's do it. Yeah, let's do it here.
I don't think it's possible. That's my answer. Because, correct me if I'm wrong, but here's this job. If we have our 4 pig pens, and we want an odd number of pigs in each pen.
Yes.
If we add up all of these odd numbers, we're going to get must be even, right?
And you make it very like, you are already thinking very advanced. That's like too advanced. Remember we were talking about hands and fingers, so definitely the amount of people will only use fingers to count and to add. So no to 1 plus 1.
Okay.
No.
Kill all the bricks.
But I really appreciate you coming here. Thank you so much. Yeah. So here's the thing. What someone did here is that he assumed that all the pens are the same size and they are gonna be next to each other. Nobody tell you that that should be what you are doing. Like nobody can tell you that. Here's what we can do. How about this? Let's have the 4 big pens, a bigger print that have the 3 big pens inside of it. So now we have pig, 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 pig. Right? No, count. They have odd, 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 and all of them is also come up to be an odd number, right? So yeah. So that's the trick that I prepared for you today. Like I have 3 minutes left. Those are my resources. I read the complete book of Chisanbop, which I found at Clemson Library. I think they also have it like available online. And I saw this 91 cool matrix that make you task that I use like most, like I would not say most, but a lot of the problems that I showed you today are from this book. And this book is $5 on Kindle, and I got mine at $2 because of the discount. Like I really love discounts, so it's like $1. So I was doing research on it's like what kind of stuff I'm gonna talk about. Remember, I only know that Chisanbop is a word, so that's the reason why it's out. So yeah, I got mine at $2. I think it's a really cool book. So yeah, that's what I got for you today. We still have 2 minutes left. Thank you so much for joining me today, and I'm looking forward for you guys. Sometimes. Yeah.
Anybody have any questions?
Yeah.
You teach a class.
Yeah, I am teaching math 1030, which is the class is called elementary functions, and it's like a pre-calculus, like some topic of pre-calculus class. So yeah, I'm teaching. I love my students. I love teaching, and I'm good at it. So.
Anything else? I have a question. With Chisanbop, I don't know if you know the answer, but do you know how if that's related at all to an abacus? Because it works on the exact same number basis.
I think it's like this. I think it's just the same idea. Yeah. It's just like this. The Chisanbop is from some Korean people. Yeah, that just come up like, yeah, we still not using the abacus. Why don't you use fingers? And they come up with ideas how to make that work. So yeah.
All right, let's thank our speaker one more time. Thank you all for coming, and I don't want to deal with pizza. Take it home.
Yeah. No.